Hi, today we're going to learn about logarithmic, and this is under college algebra review. So the first problem says we are given log base 2 times x plus 5 equals log base 2 times 1 minus 5x. So what I want to do is, notice how they have the same, whenever they have the same base of, they have the same base of log base 2. When they're like that, you just have to you can just ignore the log base and then just write down whatever you have left. So we're left, since we have the same base, I could just write down x plus 5 equals, so I could just ignore that log base, equals 1 minus 5x. So our goal is to find x. So how would I want to get one side to the right side 0, so let's get rid of this whole thing, 1 minus 5x. So we can subtract 1 and then add 5x on both sides. Okay, so on this side we have an x plus 5x, so that's 6x. And then 5 minus 1 is positive 4, equals 0. And then I can factor out a 2, so that's 3x plus 2 equals 0. I could get rid of this 2 by dividing both sides by 2. So now we're left with 3x plus 2 equals 0, because 0 over 2 is 2, not undefined. So let's solve for x. So I'm going to subtract 2. 3x equals negative 2. Oops, 3x equals negative 2, 3x equals negative 2. And I'm going to divide 3. So x equals negative 2 over 3. Okay, before I make sure x equals negative 2 over 3, I have to check it, and by checking it, I just have to put it back in the original equation. So I'm going to put it in the original equation, because checking is really important. So log base 2, and then wherever you see next, you plug in negative 2/3. Equals log base 2, 1 minus 5 over times negative 2/3. So for this part, let's get the common denominator. So this is 1. So I'm going to multiply this by 3. So that's 15. So 15 minus 2 is 13 over 3. Over here we have 1 plus 5 times 2 is 10 over 3. And then we could say 3 over 3 is the same thing as 1. So that's 3 plus 10, which is 13. 13 over 3. So this looks like it's true. So we must say x must equal negative 2/3. Okay, next problem. I'm going to clear the board. So we have 2 log base 3 times x plus 1 equals log base 3 times 4x. Okay, so let's simplify the left side. We have this 2, we have 2 log base 3 times x plus 1. Remember the log rule for whenever it's in front of the log, it's meaning you're putting it in exponent form, so it's this rule. Log base a m to the n so all they did was whenever, see, this looks like this, so whenever there's a number, they put it in, whenever it's in front of the log, they put it in exponential form. So we can rewrite it as log base 3 x plus 1, and we're going to square this whole thing, equals log base 3 of 4 times x. So we have the same base, log base 3, so we could just ignore it. So let's just bring down what we have, so x plus 1 square equals 4x. And then I know, so this would be x squared plus 2x plus 1 equals 4x. I want to get the right side 0, so I'm going to get rid of this 4x. So I'm going to subtract 4x from both sides. So this gives me x squared, and then 2x minus 4x is negative 2x plus 1 equals 0, and then we can factor this. So we need two numbers. When multiply gives you positive 1, and when add it gives you negative 2. So I'm going to use negative 1 and negative 1. Because negative 1 times negative 1 is positive 1, and negative 1 plus negative 1 is negative 2. So we're going to get two answers, x equals 1 and x equals 1. So in order for it to make sure it's true, we got to plug it in. So let's plug it into the original equation. So it's 2 log base 3, and then 1 plus 1 is 2, equals log base 3, and then 4 times 1 is just 4. So let's simplify the left side. So whenever there's a number in front, you are going to power that. So it's going to be log base 3, 2 squared, so 2 squared is 4, right? And voila, it's the same. So our answers is x equals 1 and x equals 1. So number 3 says we have log base 2 times x plus 1 plus log base 2 times x minus 1 equals 3. Okay, so I'm going to simplify the left side, and we see how we have a log base 2 and a log base 2, and then we have a plus. Well, according to the log rules, whenever you're adding something, you're really multiplying. And if you don't know the log rules, there's a section under college algebra where it's under log rules. So if you need to review it, please do it if you need to. So let's simplify this. So it's log base 2. So like I said, when you're adding, you're really multiplying. So we're going to multiply the x plus 1 and the x minus 1. Equals 3. So, okay, so we have log base 2. Let me simplify it even more. Wait, before I simplify, let me write down a very important rule for our log. So this is a rule for the log. So log base A x if and only a to the y equals x. Okay, so it says y equals log base a times x if and only if a to the y equals x. So if you have it in this form, you could put it in this form. So let's look at this equation. We have log base 2 times x plus 1 times x minus 1 equals 3. I agree that this is in this form because we have a y, which is our 3, and then we have a base, which is 2, and then we have this whole thing is called our x. So if we have it like this, now we can put it in this form. So we said that our a, which is the base, is 2, our y is 3, because it's on always at the end side, and then our x is this whole thing, right? Good. So now we could put it in this form, ay to the x. So 2 to the y is 3 equals x, which is x plus 1, x minus 1. Okay, so let's simplify. So 2 to the 3 is 8. And then this is the perfect square, so it should be x squared minus 1. Our goal is to find x, so we have to get one side that equals 0. So let's get rid of this negative 8. I mean this 8, so I subtract 8 from both sides. So I get x squared x squared minus 9 equals 0. So I know you can add 9 both sides. So you get x squared equals 9. And then you take the square root of both sides. And now remember, when you take the square root, you get two answers, a positive and a negative. So we're going to get positive 3 and negative 3. Okay, so we got two answers and we got it checked. Okay, so let's do negative 3. If we plug in negative 3 into x, we get log base 2 times negative 2. And according to the rules for log, we can never have a negative inside the log. So we can automatically get rid of negative 3 because we can't have negatives inside the logs. So let's try positive 3. So log base 2, and then 3 plus 1 is 4. Log plus log base 2. 3 minus 1 is 2 equals 3. So let's simplify this. Let's simplify the left. So this should be log base 2. And then remember when we're adding, really multiplying. So it's 4 times 2 is 8 equals 3. And then we have to put this into this form. So our a is 2 and our y is 3 and our x is 8. So 2 to the 3 is 8 and 8 equals 8. So this is true. So x equals 3. And yeah, that's how you do this. You always have to check. So let's do the next one. Number 4. We have ln of x plus ln 2x plus 1 equals 0. So we're doing natural logs, right? So natural logs are pretty much the same thing as log. They have like a base of 10, so they follow the same rules of log. So let's simplify the left. So this should be ln, and then we're going to multiply because we're really adding. So it's going to be x times 2x plus 1 equals 0. And then we can simplify, so this should be ln of 2x squared plus x. So remember the our rule. So we have to put it in ay equals x. So what is our a? See how we don't ln natural log always has the base of 10. So if there's nothing, if there's not a number down here, you assume it's just a base of 10. So we say our base is 10, our y is 0, because it's always on the right side or the left, and then our x is this whole thing. So it's 2x squared plus x. Let's put in ay equals x form. So a is 10, and our y is 0 equals 2x squared plus x. So anything to the 0 power is just 1. So 10 to the 0 is 1. And then remember we need to get, we solve for x, so we must get one side that's 0, so let's get rid of this 1. Let's subtract 1. So we have 2x squared plus x minus 1 equals 0. Good. Now let's factor this. This one's a weird one, right? Because there's a 2 in front of here. So what we're going to do is use bottoms up factoring. So we're going to use bottoms up factoring. It's not too hard because I can't use simple factoring because of that 2. So basically what you do is first you ignore this 2, this coefficient of 2, right? So write x squared plus x. And then you times 2 times negative 1, which is negative 2. Then we could factor this. So this is x, x. We need two numbers, multiply negative 2, and when added gives you positive 1. So I will use positive 2 and negative 1. Right? Because 2 times negative 1 is negative 2, and 2 plus negative 1 is positive 1. So that works. Now, remember the 2, the coefficient 2, you're going to divide it by here, 2, and the negative 1. So 2 over 2 is 1, so this is just x plus 1. And then over here, we have a net fraction, right? Negative 1/2. I don't want that fraction, so we're going to do, it's called bottoms up. So you bring this 2 in front of the x. So this is going to be 2x. And then you just ignore the 2, so you're left with negative 1. So yeah, so you just bring that 2 in front of the x. So that's why it's bottoms up factoring. And then when you solve for it, you get two answers, right? You get x equals negative 1, and then x equals positive 1/2, because you add 1 and then divide by 2. That's how you get 1/2. Okay, so we get two answers and we got to check. So let's start with the negative. Can we put in, if we put a negative 1 in front of, into the original equation, you get ln of negative 1. Remember how I said you can't have a negative number for the log? Because natural log and log are like the same thing, so you can't have a negative inside the log, natural log, so we can completely dismiss this. Now let's try the 1/2. So ln of 1/2 plus ln 2 times 1/2 plus 1. So 2 over 2 is, ln of, 2 over 2 is 1 plus 1 is 2. So we're adding, so we must multiply. So ln of 1/2 times 2, which is 1. So when you put an ln of 1, you get 0, right? Because just put it in the calculator and you should get 0. So this is 0 equals 0. So that's true. So, because you know why it's true is 0? Because remember natural log has a base of 10, so it's like 10 to the what power gives you 0. Gives you 1. So it's 0 because 10 to the 0 gives you 1. So that's why it's 0. But if you don't know, you could just put it in the calculator and you should get 0. So our final answer is just x equals 1/2. The last one, number 5. We are given ln of x plus ln times x plus 2 equals ln of 3. So I will simplify the left. So let's make this 1 ln. So when you're adding, you're really multiplying. So it's ln times x plus 2. Let's simplify. So, okay, so we both have ln, so both right and left, so you just ignore it and then you just bring down. So what is x? So x times x plus 2, which is x squared, plus 2x equals 3. So our goal is to solve the value for x. So let's get the right side 0. So let's get rid of this 3 by subtracting 3. So we have x squared plus 2x minus 3 equals 0. And then we can factor. So that's x, and then we need two numbers multiplied -3 and added +2. So let's try +3 and -3. +3 and -1, sorry. Because 3 times -1 is -3, and then 3 plus -1 is +2, so yes. So x equals -3, and then x equals +1. Okay, so let's try the -3. I don't think -3 is going to work because you get a negative natural log, so can't work. So let's try +1. Um, 1 plus 2 is 3. So simplify the left. So remember when we're adding multiplying, so 1 times 3 is 3. So ln of 3 equals ln of 3. This is true. So x must be x equals 1. One more, I lied. It's number 6, our last one. And the last one's always the hardest. So we have 3 to the 2x equals 4x plus 1. This looks really weird, I know. But see how we have a base of 3 and a base of 4, and there's no way we can make that common. So we're going to use the log rule, the natural log rule. So remember, whenever you have something in the exponents, you put it in front of the natural log. So I'll rewrite this as 2x natural log of 3. Not base 3, just 3. And then same with here. Bring that in front of the natural log. Natural log of 4. Okay, so we said, our goal is to solve for x, right? Let's simplify the right. So this is really saying x ln of 4 plus 1 times ln of 4. Okay, so remember how we want to solve for x. So let's get all the x's on one side. So see, we have an x over here, x ln 4, and then we have a 2x ln 4. Let's put that all on one side. So I'm going to subtract this ln of 4 both sides because I want to get all the x's on one side. So on the right, the left, you have 2x ln of 3 minus x ln of 4 equals, and don't forget the ln of 4, so that just stays there. I'm not going to write that 1 because I already know there's an invisible 1. So now on the left, the left side, we can factor out an x because they both have an x. So that's x times 2 ln of 3 minus 1 ln of 4 because x times -1 is ln of 4 equals ln of 4. Okay, so our goal is to solve for x, so we can get rid of, I want to get rid of this whole thing because I want to get x by itself, so I will divide everything by that whole thing to 2 ln of 3 minus ln of 4. I don't have to put the 1 because there's an invisible 1 already, and you have to do it on both sides. So 2 ln of 3 minus ln of 4. So our x is, put it right here, x equals, the numerator is ln of 4 and then this is the denominator. Okay, so this is actually a number. They'll give you a number. If you put it in the calculator, they'll give you a number. If you do put it in the calculator, make sure you put parentheses. So put a parentheses on the top and then press the divide sign, and then make sure you put parentheses on this whole thing, because otherwise you'll get a wrong answer. And then what I got was x is about approximately, I just used 2 decimal places, so about 1.7. And then you always, the last part is just checking it, so so I'm going to go back to our original equation, and we said that x is about 1.70, so it'll be 3. Okay, so 2 times, I'll just write it down, write the whole thing down. 1.7 plus 1. Okay, so 2 times 1.7 is about 3.4, so 3 to the 3.4, 4 to the 1.70 plus 1 is 2.7. And if you put it in a calculator, 3 to 3.4 is about 41.89, and then 4 to the 2.7 is 42.2. They're very close, right? Because if you round this, that's like 41.89 is about 42.0, and then this is just 40. So as long as they're really close, that means it's true. 42.0 and then 42.2. They're very close. So our x is about this value. So yeah, this section is review for logarithmic, and you basically just solve for x and then check it if it's true.